Hi there, my name's David Schwartz, and welcome to my CodeRage 9 session entitled, Have You Embraced Your Inner Software Plumber Lately? Well, lambdas and closures can help. As a means of introduction, I'll just say that I got my bachelor's degree in math and computer science from Arizona State in 1979, and I've been a professional software developer ever since, had lots of contracts, worked on my own for a while. I began Windows development around 95 when Delphi 1 was released, and I'm still loving it. And about the most interesting thing about my career is I've got a couple patents, and them and $2 will get me a cup of coffee. So, as an overview of my talk, I will first start off talking about what inspired it, and then take a tour of some code examples that are highlighting what I'm focusing on here. And take a quick detour about some terminology so you're clear what I'm talking about. We'll then explore some common plumbing code and then examine a better approach and then do a little bit of wrap up. So what inspired me for this talk is Delphi. I mean, Delphi's IDE has reduced form coding significantly, the amount of coding you have to use to create forms. But over the years, I've noticed that the percentage of code that's focused simply on moving data between objects, in and out of objects and forms, seems to be growing considerably. And this is what I call plumbing code. And I've found that plumbing code now dominates many, if not most, of the projects I work on, especially if they're not database aware, if they're N-tier or multi-platform. It's time to tackle the problem. So here's my vision. This is where I'd like to start designing apps in Delphi, with a diagram of the application. All right, Delphi is form-centric. You start out with a form. Well, this is a look at the whole application. Of course, this just looks like a DFD. It's not just an ordinary DFD, a data flow diagram. The lines actually represent pipes or wires, and they have properties. Think of something like a data bus. And it's the lines here that I'm referring to as plumbing. So what this talk is and is not about, I'm looking at the general problem. So when you're talking about an application as a main form, it can be a form or it could be a non-visual app running as a service somewhere. The data management forms can be dynamically instantiated as they're needed on whatever platform you're on, say a desktop, a phone, a tablet, even your big screen TV. And some of the other forms that are basically selection and CRUD forms, they can be embedded as frames or as pop-ups. They're really contextual extensions of the underlying forms. What I'm not talking about is live bindings and data-aware controls and forms. These have already been optimized for a particular class of problems, and more specifically, where they result in very tightly bound and highly coupled code. What I'm really looking at is something that's a level above the live bindings and data-aware controls. So what we need is some kind of a shift in perspective. Today, inside of Delphi, forms own, control, and manage all of the endpoints. The IDE is really form-centric, and the endpoints are just controls on each form. It's easy to lay out forms, but it's actually fairly tedious to move data in and out, and that's why data-aware controls exist, because they make that movement especially easy when you've got a database engine or server or something somewhere. Now, in theory, forms don't know or care about each other, but in practice, without any kind of higher level abstractions and things at the application level, forms do know about each other, and they must. In the future, the way I see it is that these pipes would own, control, and manage the endpoints. Now, I look at an application as a kind of a lens, and what it does is it focuses source data that exists somewhere, and it focuses it into a viewable portal. Forms take two forms. They take either static viewpoints for structured data, or they're interactive data viewers or editors. Now, on one end of this pipe, data lives somewhere. It can be local or remote, or maybe both. We can pull it closer for faster access by caching it. When we're done with it, we can push it out for safer redundant storage and maybe wider consumption. And on the other end of the pipe, we have the display and data entry elements that live inside the forms. This is the stuff we all know and love that's inside the IDE. Labels, fields, memos, stuff like that. So it's really easy to lay out forms today. The problem is it's hard to generalize the data movements between arbitrary endpoints, even in simple models like this. And if we look at the pipes here, we have several different mechanisms we can use to actually move the data. We can use a .assign method. We can have the assignment statement. We have live bindings. We have remote procedure calls. We can use HTTP. We can use SOAP and higher level protocols like REST and JSON, XML, SOA. All right. But what I'm seeing is after we select the endpoints and define the data aggregation properties, then identify the protocols and the encoding. We don't do that right now. We start off and say, oh, do you want this kind of application or that kind of application? And once you do, that's it. You're stuck. So we create forms, we make them talk, then we're stuck because the protocols and encoding are hard-coded into the forms. The plumbing is already rigid, and we have a lot of tight coupling between the forms, and all of that restricts our options considerably. So I'm really focusing on generalizing the form interfaces. And the question is, what would it take to focus on the pipes rather than the forms? Now, this is a potentially huge subject, and I'm really limited in time. So for now, we're going to look at the plumbing used in classes and forms. And what we're going to arrive at is hopefully improved consistency and some generalized form interfaces. And that's going to yield less coupling codependencies, more dependency injection, and will actually leverage lambdas and closures. Now, just a word of warning, a lot of this is going to be very familiar, and in fact, I'm going to zip through a lot of it really fast. You can look at the code later for more details. But some of you are going to look at this and wonder, why are we even talking about this stuff? Well, the answer is because nobody ever talks about it. The second answer is our industry needs a quantum leap in productivity to meet the global programming demands we're seeing over the next decade. You know, I've heard that by 2016 we're going to have more mobile devices in the world than people. There's a lot of applications that are going to get built and not enough programmers to build them. So we're going to have to do for ourselves in this industry what we have done for people who design aircraft and skyscrapers. So really quick tour of some data structures and classes just to form a foundation. Here is a record. We got 3 doubles in a string. I call it a name 3D point rec. And the on-click handler for this, we define 3 instances of this. We assign a value to the first point, assign a value to the second point, add the two together into result, and then display the results. Now if we take a look at the class, we have the same 3 doubles in a string, but now we have some setters and getter functions. We have some properties at the bottom here. In the middle, we have a couple constructors. The first one allows us to initialize the object with 3 doubles in a string, and the one in the middle takes what in C++ would call a copy constructor. It takes another instance, and if it's nil, it sets the values to reasonable defaults. And we've got the destructor. Then we have an add function, which creates a new instance from self, then adds the other point into it. Self is not modified. So we look at the on-click handler. We declare 3 instances of name3d.cl, create the first one, create the second one, add the second of the first one, get our result, and display the results. Then we free them all. And when we run this app, this is what we click the first one, add points using record, we get the first 4 lines. Add points using class, we get the second 4 lines, are exactly the same, and that's exactly what you'd expect. Now, let's suppose we want to create a form to edit one of these points. Very simple, 4 T edits, a couple of buttons, OK and cancel button. Very vanilla form, nothing new here. So this is what I've found most frequently, and this is the type of approach I see over and over and over again, which is the code goes out and assigns values to the components on the form directly. No encapsulation, no nothing. We call show modal. When we get OK back, we go reach right back into that form and access the T edits and pull the data out of them. Now, before I continue, I want to get a little bit of terminology here. We're going to talk about dependency injection. Dependency injection is a software design pattern, but most specifically, an injection is the passing of a dependency, typically a service, to a dependent object. And we can include passing objects. Note, it does not require the use of a service locator, and I am not discussing that further. Now, when it comes to object initialization, we have two ways we can approach it, called constructor injection versus property injection. Constructor injection is when we set dependencies via the constructors. So we have myObj, tMyObj, we create an instance of it, the constructor, we take three parameters, three dependencies, foobar and zip, and it returns us an instance, and those things are initialized inside the object. Using property and setter injection, we're setting the dependencies after construction occurs. So we take tMyObj, call the constructor on it with no parameters, and then we assign values to A, B, and C, or we call the setters set A, set B, and set C. Accomplishes the same thing, just a little different order. Now there's some pros and cons when it comes to constructor versus property injection, and they happen to be mirror images of each other. When it comes to constructor injection, one of the pros is that it's atomic with the creation of the object. In other words, you create the object and it's fully initialized. And the other pro is that the compiler can enforce the interface contract. So, for instance, where we say in a constructor, here we need 3 objects, we can't pass 2 or 4. The compiler will give us a compiler error. The drawback is all the values that are necessary must be available at the time we're constructing the object. And for practical purposes, we have a limited number of arguments we can pass. When it comes to property or setter injection, it's exactly the opposite. We can have virtually unlimited number of arguments. We can support lazy initialization. So basically we create the object and then we can inject the dependencies into it. The drawback is, well, we're dealing with an object that's not fully created, and the compiler can't enforce the contract because maybe we assign 5 properties and we need 6. So getting back to our previous example, this is what I call backdoor injection. Now maybe there's a technical word for it in the industry. I don't know what that is, but basically it's breaking all the encapsulation rules and reaching in with your hand and fiddling around with stuff that you shouldn't be touching. Why is this so common? Well, the other alternative is to create properties in the forms, and every time I've tried to do this, somebody looks at me and wants to slap me over the head and go, "Why are you doing this?" Well, because that's what we should be doing. Well, no, they think what we should be doing is this. I don't know. Anyway, but when we do property injection, we get to assign to the properties on the plumbing going in, and then we refer to the properties on the going outside, which is really nice because if we've got 3 doubles here, we might change those edits to numeric edits, and then you don't have to change the code because the implementation changes. But you know what? I rarely see this in practice. Why not? I mean, after all, properties are intended to separate interfaces from implementation, and they allow you to change the implementation without affecting the interface. So why not use properties in forms? I don't know. There just seems to be an unwritten rule against it. Now, if we look at the third variation, which is constructor injection, we have to override the constructor for the form. And that means adding these parameters in here. But then we have this little pink thing, the tag called reintroduce. If you don't put that, you're going to get a whole bunch of these warnings for each one of these constructors saying that it hides a virtual method of the base type tCustomForm. And I've seen so many projects that just have dozens and dozens of these warnings that come out. Why don't they put reintroduce? Because it breaks the inheritance hierarchy. Now here's the other curious thing about constructor injection. It works really nice to get data in, but we're stuck with the same backdoor injection pulling the values out. So if we want to add properties to extract the data, why bother with constructor injection? Just use property injection on both sides. I've never gotten a good explanation of that from anybody either. You just don't use properties. All right. So summing things up, so far, Delphi employs 4 types of plumbing. Backdoor injection, which is the most common in my experience, constructor injection, property injection or setter injection. Property is very uncommon, setters are much more common. And then DB aware injection, which is common, but I'm not covering that here. Now the point is there's very, very little consistency that I've observed in practice. Not consistency within a project, no consistency across projects, no consistency in general. In fact, I have never ever seen plumbing code addressed in coding standards. Not once. And every time I have tried to address this, it's been met with a lot of skepticism and people like, what the heck are you even discussing this for? It's crazy. Well, it turns out there's a lot of good reasons to address this topic, and I'll get into them a little more shortly. But first I want to talk about some constructor injection limitations. All right? Now, constructor injection is probably the most obvious solution for most object-oriented programmers, but it's not ideal. First of all, it breaks the inheritance chain because it requires the reintroduce tag to be added unless you like looking at dozens of warning messages. And secondly, it's okay, from a practical standpoint if you've got half a dozen fields or so, but what if you got 75 fields to initialize in your object? Well, the obvious solution is you create and pass an object that contains all the needed fields. So we create this thing highlighted in red. We have a tparm object, and we stuff all the values in there. This guy, Mark Seaman, who's written a couple of books on dependency injection, he's got a great blog. He calls these parameter objects or facade services. Now, when you switch to tparm object, nothing's saved, but you're actually leveraging some encapsulation. So what happens is, instead of having to assign to or from properties in the parameter object or properties in the form, it's kind of one or the other. So the funny thing is this parameter object begins to look like an adapter pattern. The thing is it's very specific. It's not general. Adapter is usually very general. So parameter objects, in my experience, start out with good intentions. They start out as a collection of data passed between objects. But it never fails. They're almost always hijacked and turned into more general objects. And I've observed this over and over and over again. And I found Mark Seaman actually addresses this in one of his blog posts. He says, I call such a type a facade service. It's closely related to a parameter object, but the main difference is that a parameter object only moves the parameters to a common root, which is stuffing them in the container, while a facade service hides the aggregate behavior behind a new abstraction. While the facade service may start its life as a result of a pure mechanistic refactoring, which means turning it into a parameter object, it often turns out that the extracted behavior represents a domain concept in its own right, which is why these things always get hijacked. So in other words, if you're going to use parameter objects, expect that they're eventually going to morph into more general objects. So identify the behaviors that their encapsulated data represents, define a facade service right from the outset to support that expected need, and just use that. Seaman gives some great examples on his blog, and you can see the link to it here. So, we're talking about plumbing code here. All of this is just plumbing code. And the question is, how can we begin to standardize on some of this stuff? It's all that goes into and that goes out of parts of forms. Well, we can start by identifying the different types of forms that we're working with, and then we're going to focus on one and examine a workable approach that we can take. So I've identified 4 types of forms. There may be some more, but this is what I've pretty much boiled it down to. The simplest is alerts, and these are exemplified by show message and message DLG in Delphi. On the other extreme is complex forms, the Delphi IDE, for example, or your typical common application that's got, it's a main form, it's got menus, list grids, all kinds of stuff on it. And what these things do is they pull up their own data and they interact with other forms. They read from the registry, maybe any files, text files, database, servers, wherever, okay? And they manage other forms and resources, including specifically the security stuff that you may need for accessing fields or even fields in other forms. Now there's 2 other types that are a little more interesting that we're going to focus on here. Selection forms are forms that map multiple domain-specific data options into a single external or internal value. And these things typically accept a whole bunch of different data values, and then they return one as a selection. For instance, select a customer by name. You give it a list of 487 customers, and it gets back one customer ID. Or a file open dialog is another good example. And you browse through your file system and it returns one path name. CRUD forms are CRUD stands for Create, Retrieve, Update, and Delete, and they're typically used for database access. And if you're not using data-aware components, you probably need 2 or 3 of them. Now, sometimes these are all in one form, but more than not, there's usually one for viewing and one for editing, because some of the logic is kind of messy when you got to set it up that way. And the initialization and business rules can actually be very different on add versus edit forms. And the usage of add, view, and edit modes can come from different places. So depending on your security, it's sometimes easier to actually have separate forms than to try to put all of this stuff in one form. We're initializing and retrieving data to and from forms. When we're dealing with alerts, we simply pass parameters to a method, okay, like show message. And if you use something like message DLD, it may get a function result returned. With complex forms, they're usually standalone or self-contained. There's not much else to deal with. Selection forms will have one or more initializers, and they can have a lot of data in them, thousands of things to search from. But they'll usually have a single extractor, which returns one selected item. Now, the neat thing with selection forms is they can actually be embedded as T-frames. They can exist as, say, pop-up dialogues, or they can exist separately just as separate forms. CRUD forms are characterized by one or more initializers and extractors, and they frequently have multiple variations of the same form. So we're going to focus on selection forms here. What are they? So say select customer. You give it a list of names and you get back a customer ID. You give it a list of transactions, you want to select an invoice and you get back an invoice number. If you want to select a medical procedure, you give it a list of procedures and you get back a billing code. If you want to select a product, give it a list of products and images maybe, and you get back a product ID. They're typically read-only. You don't edit selection forms. You can use a lot of technologies to implement them. Combo boxes are really simple, but they're not forms. There's no plumbing, so all you do is stuff a bunch of things into the items property. They could be, like I said, embedded on T-frames, pop-ups, separate forms. They could be text boxes with incremental key search. You're not actually modifying anything, but you do have some interaction on the form. They could be radio buttons or groups, lists, grids, any variety of things. So here's a really simple selection form example. I've created this is for selecting your favorite NFL team. This is football, American version of football for those of you in the rest of the world, not soccer. We happen to have 8 leagues in the National Football League, and each league turns out has 4 teams in it. So in the example, I have a little team memo that I pasted some data in, and you can see that on the right here. It's just a list box, and we can. I'm using that to power this example. So when you fire this thing up and you look at the form, you basically select a league, a radio button on a league, and it brings up the list of teams in that league. Then you select the team that you want and click the OK button. This is a very simple example of a hierarchical or master detail data selection scenario where the main category in this case is static. So you'll notice the league, I actually hard-coded the names in that radio group, although they could just as easily have been generated dynamically. In this case, we have leagues, and they subdivide into teams. Could also be, say, cities, and then we have offices or restaurants or facilities or whatever in each of the cities. Could be clinical, medical departments in a hospital, and then the detail areas, the doctors who are on call. The master area could be automakers, and then the details could be the models. Okay, so another example here that I'm adding in is the use of another form of injection, which is setter-getter variant. So we're not using properties, we're using just setter and getter. We have an initializer we call add team, and this adds the values. So you see on the form it just says under team, says team 1, 2, 3, and 4. We call add team to actually specify the league and the team associated with that league. So we'll have 4 calls for each of the leagues for 4 of the teams. And then at the end, When the user hits the OK button, we call getSelection to get the selected team back. And what happens is in the main form, we have the team data. We just loop through it and call add team for each of the lines in the team data string list, and that thing simply in the selection form adds them into I added a string list onto the objects array associated with each of the items. Could be done any number of ways, but that's how I did it here. So the form comes up, the user clicks, makes a selection, clicks the OK. Our code looks for the MROK, and when it finds it, it calls getSelection. Now you also want to be sure that you pass CA hide to form close and not CA free, because we're calling the form, we're calling a method on the form after control is returned from the form. And this is what getSelection does. So there's some drawbacks to these approaches. First of all, they're all tightly coupled. They're very, very hard to unit test because everything's pretty much cast in concrete in the code. Now, we'd like to use interfaces, but they're not generally available. So there's no like IForm to go along with TForm or ICustomForm. So what can we do? Well, we've got 4 types of forms we're working with here. So we could create interfaces specialized for each one of them. So for the alerts, we can create an IAlertForm interface. And when you pull up the code associated with this, you'll see that I've already done that, and it's got some methods in it. We can create some specialized interfaces for selection forms. So we'd have one for each type, maybe getFile, getDirectory, or say getCustomerID. CRUD forms are a little different. We might want to create a generic base like iCRUD form base, and then create specialized forms for each of the types of forms, which would be like create form, retrieve form, update form. And for the delete, there's not a form, but usually a confirmation. Complex forms, well, we might want to use frames or embedded forms on them and create an interface for each one as needed. Now, there's the other problem that a lot of dialogues and forms very frequently will mix logic and presentation attributes. So what we might want to do is create separate subinterfaces for each one. So if we have IMyForm, we might want to compose it of myForm presentation, which has things like all the presentation attributes, captions, font styles, things like that, and then IMyFormLogic. And that interface is going to depend on the type of form. So for instance, if we're working with alert forms, the show message method we might want to hide behind just the show method. We could create for message DLG variations, show warning, show error. When I like get YN or get a yes no confirmation, or even really abstract it out and have a confirm method. So we'd say if confirm, are you feeling lucky today, then, versus if message DLG, are you feeling lucky, empty confirmation, MB yes, MB no, 0, M equals MR yes. Much easier to read when it just says if confirm, right? Now when we're working with selection forms, we have 2 main attributes. We have field initialization that goes in aside, and this is basically just in init fields, and we're sending a whole bunch of stuff in through one pipe. And we can actually send in rows of delimited query result data, say like CSV data, rows of CSV, or even structured data like XML or JSON. On the field extraction side, it's really simple. Usually we're getting a string or an integer back, so we just call getSelection. And this is also where we happen to hide the show modal call. Now, happens that anonymous methods or closures are ideal to use here. CRUD forms, we want to remember that we typically operate on single records, which are collections of fields. We have field initialization, process, and then field extraction. For the initialization side, we're using init fields, and everything's going through one pipe. We could send them field by field. We could send them as a single row of delimited data, say like CSV data, or we could send it as a structured data element, XML or JSON. Process is going to vary depending on whether on what type of access we're going to have. Do we need read-only? Is it like a view field or browse? Is it what I call a naked edit, which is like a create new with all empty or defaulted fields? Or is it a pre-populated edit, which is what you'd use for updates? Now you might also have an optional callback method to use for field validation. On the field extraction side, Well, we could pull them out field by field, single row, or structured data. It's really all up to you. And again, anonymous methods or closures are really ideal to use here. So I'm going to really quickly, this is a classic selection form interaction. Focus on the yellow highlighted lines. We declare an instance of the form. We create the instance of the form. We have a loop which takes each of the lines in the string list and it calls add team to inject that into the form. Then we call show modal, wait for OK. When we get it back, we call get selection, then we free the form. About as generic as you can get. Now, when we convert this thing over, say, ITeamSelection form interface, well, we have two methods, what I showed earlier, init fields and get selection. But the implementation of this is not quite what you'd expect. So we're going to put a private instance of the form here and two protected methods, which are the implementation of the interface. The public interface part of this is one thing. It's just a constructor. Okay? What we're doing is we're passing in the requisite owner member and two lambda functions or two closures, anonymous methods. Okay? So we have three parameters. And this is constructor injection. Now how that looks in the implementation side, this is the method that's called to actually implement this. All right, so we've got a lot of colors going on here. The green is the list of data that gets sent that's initialized in the form. Okay, so we start out, if you follow the yellow, this is the we declare self form is an ITeamSelection form, and then we create an instance of the TeamSelection form, the class. All right, and we pass it. First parameter is self. The red arrows are the parameters. First is self. Second is our function that returns a string. And the third is a procedure that takes a string argument. Now, the function, it's just called, and it just returns data line by line by line by line until it's through. And then it says, OK, I'm done. So it returns a null value. The second method here is called after the user clicks OK or cancel button. And this is a plumbing coming out of the form. So it takes whatever, if the user clicked OK, it grabs that selection and passes it through as a string argument here. Or if they click cancel, it passes the empty string. Now the thing to note here is, look, no show modal call. All right, we have one constructor call and an assignment to the result of this method. That's it. Isn't that fascinating? So simple. Now, if we look at the form, okay, this is the implementation of the form side. This is really simple. The constructor is about what you'd expect. Creates an instance of the form, saves the local variable, calls init fields, calls get selection, and then frees the form. The get selection here we take is a parameter. It takes in the tproc string argument and calls show modal. When it gets OK, it gets the selection, and then it passes the selection through to that lambda function. And by default, it's set to the empty string. The init fields method's a little longer, and I jumbled it around here so that I can put get field in a while loop, and it looks really simple. So we call get field as long as there's something being returned, then it keeps going. And this just happens to use, I separate the values by a colon and use an asterisk in front to identify the league names. So it just keeps looping through this thing, calling the highlighted function. It calls that initfunc, which is our function returning a string, to get the data. So what have we learned? Classic Delphi form interactions, the plumbing part, are really quick and easy to lay down. They're also form-centric. So they focus on forms, managing the endpoints, which is components on each form. But in a bigger context, they're brittle and inflexible. You don't want forms talking to each other because those become tightly coupled. And because of that, we can't really implement unit testing. And also the tight coupling means that these applications are not easily extensible or retargetable. Now if we take a pipe-centric design, we can employ interfaces. And this yields a new approach to the plumbing. The interfaces require a little thought and attention, which is why we say, embrace your inner plumber, grasshopper. So pipes now will manage the endpoints. They require little different mechanisms, but based on the type of the form, whether it's alert, a selection, a CRUD, or complex form. And in this case, anonymous methods are your friends. And just because I see this coming up a lot, I just want to answer it. Yes, Delphi does support first-class anonymous methods, believe it or not. However, Delphi syntax makes them very cumbersome to use at times, and in some cases very, very cryptic in their verbosity. So some syntax improvements like what's been added to Java 8 would be, I think, really, really welcome. So how about some recommendations? Well, the first one would be add plumbing specs to coding standards. I've never ever seen them. It'd be really nice to see them, like somebody actually thought about it. Then create interfaces that hide plumbing between forms. So first define your interfaces, then refactor the plumbing. And what you want to do then is eliminate your form constructors, your properties, and your backdoor injection. And then you want to replace that with simple setter getter methods, like what I did above. And if you need to send a whole bunch of data, then define some facade services and employ them where needed. You also want to leverage constructor injection on the interface classes, like what I showed you just a little bit ago. You want to use callbacks through anonymous methods. And then this will allow you to inject and extract data on whatever granularity you want. It could be field by field, could be row by row, could be structured data. So in conclusion, it's possible to shift from form-centric to pipe-centric paradigms without too much trouble. In doing so, we're going to define some standard interfaces. And this will simplify your plumbing considerably and hopefully lead to some kind of automated design tools. Also decouples your forms. And it enables the use of stubs and mocks for unit testing. It really should be possible to replace a form with a stub or a mock. But it's not if you're actually reaching inside and setting and getting values out of t-edits that are on the form. So, hopefully, by embracing your inner software plumber, you'll never look at basic form interactions the same way, ever again. So, here's a link where you can download the files from this talk. And now we open it up for Q&A.